All right, let's get right into it. We all see the sun every single day, right? But have you ever really, truly stopped to think about what it is? It's just always there, a constant, reliable source of light and warmth. And it's been doing that for an almost impossibly long time.
I mean, let's just let that number sink in. 4.6 billion years. Think about anything that burns here on Earth. A campfire, a candle. You're lucky if it lasts a few hours. So what is the sun's secret? How has it kept this fire going for billions of years without just, poof, going out?
Well, here's the big reveal, right up front. The answer is, it hasn't. The sun isn't burning at all, not in any way we'd recognize. It is not a giant ball of fire. The truth is actually way more powerful, and frankly, a lot cooler.
So, okay, if it's not a fire, what in the world is it? Well, the answer is a process that powers every single star across the universe. It's time to meet the sun's real engine, nuclear fusion.
Yeah, forget burning wood. This is more like a cosmic scale pressure cooker. Down in the very center of the sun, the conditions are so insane, so extreme, that they actually force tiny atoms to literally merge together. And when they do that, they unlock an absolutely staggering amount of energy.
Let's walk through it. First, you need heat that you just can't even comprehend. We're talking 15 million degrees Celsius. Then you add crushing pressure. That heat and pressure squeeze hydrogen atoms so violently that they have no choice but to fuse together. And in that process, they become a brand new element, helium. Now here's the magic part. During that switch, a tiny little bit of their mass doesn't just disappear. It's converted directly into a pure blast of energy. And that energy, that's the sunlight we feel on our faces, 93 million miles away.
And just to give you an idea of the scale we're talking about, this isn't some slow and steady process. Every single second, the sun transforms 600 million tons of hydrogen into helium. It's this unbelievably powerful natural reactor just running nonstop. Okay, hold on. If there's this gigantic, continuous explosion going on in the sun's core, that leads to a pretty obvious question, right? Why doesn't the whole thing just blow itself to pieces?
The answer is a kind of perfect cosmic standoff. You can picture it like an arm wrestling match that's been in a dead tie for 4.6 billion years. In one corner, you've got the insane outward blast of nuclear fusion, trying to blow the star apart. And in the other corner, you have the sun's own massive gravity, trying to crush everything down into a tiny little point. And this perfect tie, this flawless balance, has a name: hydrostatic equilibrium. It's the state where those two monster forces are perfectly matched. The push out equals the pull in. This amazing stability is the very reason our sun has been so reliable for so long. It's not too violent, not too weak, it's just right, all thanks to this equilibrium. So even a super efficient reactor like the sun can't run forever, right? It has to have a limited fuel supply. So the big question is, how much gas is left in the tank? And here is some seriously good news. Even after burning through 600 million tons of hydrogen a second for 4.6 billion years, scientists figure the sun is only about halfway through its fuel tank. That means we've got a solid 5 billion more years of sunshine to look forward to. Our star is basically middle-aged, just hitting the prime of its life. We all know the sun's important, but to really, really feel it, let's do a quick, kind of scary thought experiment. What if, right now, the sun just vanished? Well, we wouldn't know for a few minutes, because light takes about 8 minutes to get here. We'd have that last little bit of daylight, and then click, total permanent darkness. The cold would rush in almost immediately. In just 1 week, the average temperature around the globe would drop below freezing. And in a month, we're talking negative 70 Celsius. The oceans would start to freeze solid. And for life, the outcome would be quick and absolute. Photosynthesis would stop instantly. The entire foundation of the food chain on this planet would just crumble. Plants would die, then the animals that eat the plants, and on and on. Without the sun's energy, Earth would just become a cold, dead rock, drifting silently through space.
Okay, so thankfully that's just a what-if scenario. But the sun does have a final chapter. So let's talk about his actual scientifically predicted future way, way down the road.
In about 5 billion years, when that hydrogen fuel finally starts to run out, that perfect balance is going to break. The sun will swell up, transforming into a red giant, so huge it will probably swallow Mercury, Venus, and maybe even Earth itself. After that phase passes, it'll puff away its outer layers, leaving behind just its super dense core, what we call a white dwarf. And that little remnant will just spend trillions of years slowly cooling down like a final glowing ember in the dark.
So the next time you step outside and you feel the warmth of the sun on your skin, just take a second to remember what you're actually feeling. It's the raw energy from a 4.6 billion-year-old nuclear reactor, held in a perfect, delicate balance, making everything we know and love possible. It's not just some light in the sky. It is the backbone of our world. And it really makes you wonder, what other cosmic engines are out there powering worlds we haven't even dreamed of yet?